Good morning, everybody. Welcome to my talk, which is Ouch, what I learned from being hit with a serverless Ruby Boomerang. And I'm going to talk about serverless, the FN project, which is an open source project that I have kind of become a contributor to, and the dangers and upsides of getting involved with open source serverless. So my day job is not working on the FN project. My day job is I'm a cloud architect at Oracle, which means I work with our partners and our customers to help them design, build, deploy, and run their applications on top of Oracle Cloud. I'm also an accidental Rubyist. Now, how does one become an accidental Rubyist? Well, it starts with putting on a set of blinkers. So I started out programming in Fortran, and then I moved on to C, and then Java, and a bit of Eiffel. And I acquired this prejudice that dynamically typed languages were fundamentally unsafe. They should not be used, and if they were used ever in a production system, the world would come to an end. And then, a few years ago, Oracle acquired Sun. And shortly after that, I found myself on an email thread where a very senior guy, very smart, 2 PhDs in engineering, wrote this email and he said, it is not possible to run and build mission-critical systems on x86 and Linux. I thought, that's a bit strange because all of the mission-critical systems that I work with are written, they're run on top of x86 and Linux. And I thought, am I ever that blinkered? And I thought, you know what, I am. Because I have this viewpoint that dynamic languages are unsafe and you can't use them. And actually, if I look out into the world with my blinkers off, I can see there's plenty of people running on Python, Django, or Ruby on Rails. So I decided that I should give dynamically typed languages another chance. And I should learn one. Now, at the time, a lot of my friends and colleagues were starting to get into Python in a big way, but I'm slightly oppositional. The village where I grew up, 90% of the people support Ipswich Town, and the other 10% support Norwich, which meant that I automatically became a Norwich City supporter. It's not that smart a move at school, but it is what it is. So I decided that I would learn Ruby. So I got a book on Ruby, and then I started making myself use Ruby where otherwise I would use Java. And we get to the point today where it's my go-to programming language. And then, having taken off one set of blinkers, I then decide to put on another, because I start to then go around at work in Oracle and hassle product managers and say, I think you should do a better job of providing Ruby support for your product. And that's actually quite safe in a traditional enterprise environment, because there's the product manager, and then there's the engineers who work for him, and they're the only people who touch the code. But shortly after that, I tried the same trick again with the FN project. So I heard about FN project. I knew some people at Oracle who were involved in it. And I looked, and I saw that it did, in fact, have a Ruby FDK. And there were some things I thought should be improved about it. So I went and I spoke to one of the guys I knew, and I said, this is great, but I think you should do this and this and this and this and this. And he was like, yeah, those are really good ideas, Ewan. But we've got limited bandwidth. You know Ruby, so why don't you roll your sleeves up and do the job? Which wasn't what I'd meant at all. I was like, no, okay. And then you've got a moral dilemma, because either you have to start contributing, or you've really got very little authority when you try and get people to do other stuff if you're not prepared to do it yourself. So, FN, what is FN? FN is serverless. Now, the CNCF definition of serverless is as follows. Serverless computing refers to the concept of building and running applications that do not require server management. It describes a finer-grained deployment model where applications bundled as one or more functions are uploaded to a platform and then executed, scale, build in response to the exact demand needed at the moment. That's the formal definition. I actually think it's really like this. Yeah? We want the good stuff. We want to have the nice burger on our plate, but we don't want to see the somewhat unpleasant process that got it to our plate. So what I really think serverless is about, it's actually about abstraction. So we've abstracted away the infrastructure and the operations associated with it. And when we build our applications on top of this abstraction, we can say we're constructing a serverless architecture. And as developers, we can then focus on just delivering the business logic as a set of functions, which will be run using functions as a service, which is the compute component in a serverless architecture. So when we're writing for function as a service, what we do is we write small functions. Because they're small and short, they should be quick to write, they should be easy to get right, they should do one thing well, they should be easy for other people to understand when they come to look at the code, including ourselves in 6 months' time. They should be easy to maintain, and we then run them on our serverless platform and only pay for the resources we consume at runtime. It also avoids this scenario, which I've certainly encountered, where the business asks you to go and do something. There's a bunch of setup work that you have to do beforehand, but as far as they're concerned, you're just wasting their time and money. Can you not get on with writing the thing I wanted you to write? With serverless, all that goes away because that's been taken care of in the butcher's shop, and we're just focusing on giving them the nice burger. So, upsides to serverless. It should make development easier. It should improve developer productivity. It should increase our agility as developers, which should help us make the business more agile. And it should allow us to reduce our costs in terms of development and operations. And if you look at the University of Berkeley report that came out in March, they again highlighted improved programmer productivity and cost savings are two of the benefits of serverless. Now, if there are upsides, there must be downsides. The biggest one that I see at the moment, potentially, is Shiny. Yeah, we've had loads of serverless talks here at this conference. Everybody wants to do stuff that's serverless, and it's going to rapidly get to the point that people put on a new set of blinkers and say the only way to do anything is serverless, and then they'll misapply it, and then they'll say, well, it's not very good. I think you misapplied it. That's the problem. The other thing is that you have the opportunity to really snooker yourself even better than you could with microservices. So with microservices, there was an anti-pattern called Ball of Mud, which is where you have coupled microservices, so it's basically a distributed monolith. With functions, you're going to have loads more of those. So if you can couple those up, you can create an absolute monster. The other issue is around lock-in. So you can't necessarily take something that was built on one serverless platform and just go and run it on another platform. You may also find that your choice is restricted, for example, in terms of languages that you can write your functions in or where you can run your functions. And in some cases, you may just find that the platform or framework is too prescriptive or too opinionated. So in my view, when you're choosing a serverless platform, you're actually choosing a gilded cage. It might be a very nice cage, but I think you need to be sure that that cage has got enough freedom for you before you get into it. You also ought to work out how much effort it's going to be to get out of it if you decide you don't like being in it. So people say, yeah, oh, well, lock-in, you're really just talking about switching costs. Well, yes, we are, but there's switching costs in terms of time, and there's switching costs in terms of money. And if you've only written one function on a platform, then the switching cost is going to be low and the time's going to be short. And if you go and write a lot of stuff and then try and move it, you're going to pay a high cost and there's going to be a lot of time taken. So in a way, what we're talking about is risk. And I see the degree of lock-in that you have is a combination of what's my cost in time and money to switch and what's the risk that I'm going to have to switch. The most common lock-in scenario that people talk about is that your serverless provider decides, you having put all your stuff on there, that they're going to jack up the price by 1,000,000% or something. I'm not sure that's actually that big a risk, particularly given that all the cloud providers tend to have a history of cutting their prices rather than jacking them up. So it's a risk, but maybe a low one. I think this is a bigger risk. Your cloud provider gets jealous of your success, and you go into work one day, and whatever it is you do as a business they announced that they're moving into the same business. Now, how happy do you feel about running on their platform? Do you want to be able to move relatively quickly and at low cost? Do you want to necessarily commit everything to one platform and run the risk that if there is an outage on that platform, you're out everywhere? Would you prefer to be able to run across multiple clouds, say? Do you have legal or policy restrictions that prevent you using particular clouds? I was having a conversation with somebody only yesterday who was saying they can't do serverless on a public cloud platform for regulatory reasons. And finally, do you trust necessarily the government that regulates your cloud provider, or do you trust your own government? Now, I'm aware that this might sound a little bit tinfoil hat, but I do work with people who have some or all of these concerns. And I think what they're really seeking is a sufficient degree of freedom within the cage. So freedoms that matter or I've had asked to me, freedom to choose the language that you write your functions in. Freedom to choose where your functions run. Vendor independence. I know people who either personally or the organizations they work for have the scars from being dependent on a particular vendor, and then that relationship goes bad and it's been difficult for them to get away, and it's just been generally unpleasant. Portability. Do you want to be able to move your stuff from one cloud to another, to on-premises, or do you want to run with some kind of decentralized model where you have multiple clouds at a time? Or are you doing stuff where privacy is a particular concern for you? So these freedoms matter to people. And the ultimate freedom that people have is, or want, is the freedom to, if necessary, take that platform and make it their own or create their own version of it. And all of this leads people to open source serverless. And there are a number of open source serverless projects out there. I'm going to talk about FN because that's the one that I've worked with most and contributed to. And ultimately, the freedoms that you want come from open source. Now, for me, the freedom that really mattered was language. Because the situation's better today, but if you look back 18 months, 2 years, none of the cloud providers' function as a service platforms supported Ruby, or Rust, or Erlang, or Fortran. People do still write in Fortran, and they want to be able to use serverless. So I was really pleased when I found out about the FN project. So it is an open source serverless compute platform. It's language agnostic. You can run it on any cloud. You can run it on premises, basically anywhere that Docker will run. There's a large team. There's over 75 contributors, including me. We have support for cloud events. We're backed by Oracle, but independently governed with representation at CNCF. And we have a promises-based orchestration mechanism to orchestrate your functions together called Flow. We basically model the function as a container. So the function and its dependencies get rolled into a Docker image that has a single purpose. The function within should be stateless because it's going to be ephemeral. You're going to run it on demand, and then it's going to go away. So our function is a small chunk of code that we've wrapped into a container image. There's a descriptor file, which is func.yaml, because you absolutely have to have a YAML file somewhere these days. It gets its input via HTTP stream, which is HTTP over Unix sockets, and environment variables that are set for the function container when it's spun up. It writes its output back on HTTP stream and the logs to syslog. When we do a deploy, you've got your code, then we do a multi-stage build of the container. The YAML file contains a version, so we bump that. We push the container to the registry. Could be Docker Hub, could be a private registry you own. And then we create or update function endpoints as appropriate. In terms of the endpoints, FN deploy creates a single default endpoint that is used internally by the CLI. As you can see, it's not necessarily the most friendly URL or most memorable, and you only get one for function deployment. So we also have a way of creating more human-friendly URLs. This is called triggers, and you can have multiple endpoints or multiple triggers for the same function. So you could, for example, give internal people a different URL to external ones and protect those URLs differently. You can create triggers on the fly using the CLI, or you can declare them in the func.yaml. There's also the concept of the FN server, which is like our API gateway. So this manages apps and functions, and for the purposes of FN, an app is a group of functions. It's basically a namespace. FN server handles our function invocations. It itself runs as a container, so it runs anywhere Docker does, and it hosts the function containers using Docker in Docker. As we use Docker in Docker, we don't have to worry so much about what the external version is of Docker versus the internal version. And the request process goes something like this. In production, you're going to have a load balancer and an array of FN servers. But basically, the request's going to come in. The FN server will say, do I already have a running instance of this function container? If I do, then let me send the request there. If I don't, I'll spin up a new one. I'll execute the request. I'll pass the data back to the caller. I'll write anything that needs to be written to the logs. And then the function container will continue to be available for a default period of time. It's 30 seconds, but you can configure it up and down. And if we get additional requests in that period of time, then we'll reuse that container. So one of the things that your function development kit has to handle is the scenario where you get multiple invocations. FDKs make it a lot easier to write the function. So as a developer, you include the package or library or gem or whatever your language calls that kind of thing. You write your function to the FDK's interface, and the FDK takes care of parsing HTTP stream, providing the input data to your function, and writing the output and errors. We have FDKs for Python, Ruby, Java, Go, Node, and .NET Core. If you don't have an FDK for your particular language, you can also, you can use either bring your own Docker file, or you can bring your own Docker image and build a function around that. So here's the anatomy of a function. This is hello world in Ruby. So at the top, you've got require the FDK. Then we create the function, and in this case, it just says, have you got a name field in the input? If you have, hello name, if not, hello world. And then we call the handle method of the FDK. So the Ruby FDK, which is what I work on, works as follows, but all of the FDKs will follow this path. So the container comes up. We open a socket inside the function container. The FN server then connects to that socket and sends the payload over it. The FDK will parse the input from HTTP stream and then execute the function, giving it the input and the context, which is like core metadata, environment variables, that kind of thing, and sends the output back on HTTP stream and does any logging required. So this was the point at which I got hit with the boomerang, was when I was looking at the FDK. The core of the project is written in Go. I look at the FDK. So I made some suggestions about ways I thought it could be improved, and then I got asked to implement them myself. So starting out, the first thing I had to figure out and really understand was how it works. And I would do the same again if I was working with another open source project. And how it works is an interesting one. So you start out with, I can use this thing. Yes, you can. You've learned enough to be a user. But to actually start working on the project, you have to understand where all the bits are and how they relate to each other and what calls what. So there is a much steeper learning curve, and you have to get a lot deeper understanding of the project. You also have to understand how the project is structured, how it's laid out in terms of the Git repositories, and how the things in there relate to each other. So if you change something over here, whether there's going to be a knock-on effect on something over there that you've got to either go and update yourself or ask somebody to go and update. If your project has contribution guidelines, I recommend that A, you read them. B, that you do what they say, because the people who have set the project up have thought of ways that they want people to contribute, and it helps if you follow those guidelines. Otherwise, you're not really contributing, you're hindering. Part of that is understanding what the communication channels are for the project. So in FN, we have two principal communication channels. One is Slack, on the Slack workspace. Most things happen around that. And there's also the comments and reviews around pull requests. The other thing that you need to understand is who you're going to be communicating with. Who are the people involved in the project? What are they like? What areas of knowledge do they have particular ownership? You know, you want to be able to go and ask the questions to the right people. You also need to be aware of what time zones those people are in, for instance. There's no point sending a message at 9 o'clock in the morning in the UK to somebody who lives on the east coast of the US. And you also need to get your head around what are the processes and practices that we follow in that project when somebody makes a change or makes a proposal. How do we get that through into the build? And what are the individual things that have to be built? So for the FDK, the build culminates in a Ruby gem that people include. For FN itself, it culminates in a container that is put up that people can then download. So that's kind of what I had to get my head around. What I've actually done, the first issue that needed fixing from my point of view was to do with JSON. Now, at the time, we didn't use HTTP stream. At the time, we actually took our input on standard in and we sent back on standard out, and you could specify the format type that was coming in. One of the issues was if JSON format was specified and 2 JSON documents were sent in the payload, the FDK didn't cope with that well. So that was my first issue to solve. I fixed that. Then we had some additional formats that we needed to support, so added support for those. And this was kind of quite a sort of reactive exercise, a learning, getting to know the guy who had been maintaining the FDK previously. Then I got to the point where I actually wanted to start making changes. And this is where you start to get into negotiating with the other person. And you have to be diplomatic. You don't want to say something that someone's going to feel that you're dissing their work. One of the things was around coding standards. So the code we had at the time didn't follow the Ruby style guide. And it helps if you can reference the community at this point. So actually go and say, well, really, we should be looking at stuff that's in the style guide. And we should probably include Rubocop as part of the build process, because that will ensure that there's an automatic check that we follow the style guide. And where we want to deviate from it, we'll actually explicitly document that. So that was one negotiation. Went OK in the end. Slightly more tricky was modernizing some of the syntax. So with modern Ruby, certainly with stuff that's externally facing, the received best practices, you should be using named parameters. We had an API change that was being made at the same time, so I managed to sneak that one in there. Again, partly by referencing some of the experts within the Ruby community who very kindly responded to private emails. So I got that negotiated through. And then, no, that's not what I wanted. Documentation. Yeah, if you want to get involved in an open source project and be appreciated really quickly, offer to write the documentation, because everybody wants to write code, but nobody wants to write documentation. So we had to update some of the documentation. And beyond that, there's tutorials. Now, documentation is important, but if you want to get people to use your project and carry on using it, tutorials are actually really important, because they're probably the first thing somebody's going to look at. And if they try the tutorial and it works, that's a good experience. And if they try it and it's bad, that's a bad experience. So tutorials, I think, are actually really important. So got the tutorials updated, got the documentation updated. And in the course of that, the guy who had been maintaining the FDK previously decided he was going to move on and leave the project. And so it was like, well, who's going to maintain it then? All eyes turn on me. So I kind of took over maintaining the FDK, which wasn't that bad because we had a reasonably stable thing at that time. I was quite happy with it. It wasn't too onerous. Remember, this isn't my day job. And then I went on holiday. Yeah, that's another top tip. Never go on holiday if you're on an open source project. Because I got back and there'd been a major change to the API while I'd been away. So we'd moved away from standard input, standard out, we'd moved to HTTP stream, and we'd introduced the concept of triggers. Okay, that means that the FDK now no longer works. So it needs fixing. Unfortunately, my boss had a month of work lined up for me, which meant that I wasn't going to be able to do this. And this caused me a bit of personal anxiety because I really wanted to do that, but I couldn't. I just didn't have the time, and you have to be honest about that. So my day job created somebody else's rush job. The guy who did the rush job was a Go programmer, so we wound up with a big sort of slab of Ruby as Go. But it worked. That was the key thing. It worked. We had a working FDK that honored the contract. I might not have been particularly happy with the code, but it worked. And what that did was buy me time. So when I got back from doing the month of stuff my boss had lined up for me and I could get some time to work on this, I was able to refactor it into more idiomatic Ruby. So we seem to be, today, back to a stable FDK. What I want to do going forward, because there's always stuff to do, I want to improve the test suite. I prefer a sort of spec-based testing approach, so I want to switch it to RSpec. Flow. I mentioned that FN has a promises-based orchestration mechanism. At the moment, that's not part of the Ruby FDK, and there's a separate library with the other FDKs as well. So I want to create a Ruby library to support Flow. I also want to have the option of using Truffle Ruby as a runtime. Truffle Ruby is the Ruby implementation on top of the Graal VM, and it's considerably faster than MRI Ruby. So I want to do that as well. And I know this kind of by definition isn't Ruby, but I like programming languages that start with R. I want to implement a Rust FDK, because at the moment you've got to do that as bring your own Docker file. What I've learned, the first thing, and it shouldn't need saying, but I'm going to say it anyway, is you should be polite. You're joining somebody else's project. You should be polite. You should not sort of go in with a sort of bull in the china shop approach. And you should remember that you're going to have a steep learning curve because you're going to have to learn this project in a lot more detail than when you were simply a user. Sometimes you might look at the code, you might look at the documentation, and you might think, I'm not sure about this. It's always better, in my view, at that point, to actually ask for clarification. The question might make you look a bit dumb. You might feel a bit dumb asking it, but you won't feel anything like as dumb as if you've gone and worked for 2 weeks on the wrong assumption. In fact, I've found, certainly with the FM project, people have been incredibly helpful, and I think you should try to be as helpful yourself. When you know an answer that's on the Slack channel, you should give the answer. That saves somebody else from having to waste their time. And you can't be possessive about the code. By definition, you've donated it to the community. It's not yours, and you know the thing with the API change and me not being able to do it, I really wanted to do it, but you just have to go, actually, it's more important for the project we have a working FDK than my ego gets buttered up. And you need to focus on what you bring to the project. Some people bring domain knowledge, you might bring a particular piece of technical knowledge, but focus on that and focus on making the maximum contribution around that. The other thing that I think is really important is to respect other projects. As I said, there's a number of open source serverless projects out there. I know people who work with OpenFAS. There's been some talks about that here. I know people who work on OpenWhisk. They have never been anything other than really friendly towards me. I hope they would say the same back. And I think what we should do is share, exchange ideas, because that's how we make progress. Time. Time is critical. You really need to manage your time carefully. My suggested prioritization is as follows. First of all, your family. Your kids are never going to remember your pull requests. Second, work. You know, if you're not being paid to do this, the day job's kind of really important for paying the bill. And you know, you're not going to, with the best will in the world, spend all weekend coding, particularly if you have kids and other things that you need to do. So I think you need to be responsive to the requests of your team, but you need to be honest. Set realistic expectations. If you're not going to be able to do that thing for a week or a month, you need to tell people quickly when they ask, and then they can plan around that. And you also need to be honest with yourself. You know, as I say, you're not going to be able to set aside 3 days and code all night on those 3 days. And if you do get any opportunity to align what you do with the day job, then take it, because you can kill 2 birds with 1 stone. I try to get others involved. I talk at meetups. I talk at conferences like this. Slack seems to be our gateway drug. So people who join the Slack workspace tend to become users, and then afterwards they tend to become pushers, either in the Git sense or the promotion sense, or both. That's how we got the .NET Core FDK. It was a community FDK, not officially part of the project. Why get involved? Fun. I've actually really enjoyed doing this, hard as it has been at times. I've got a real sense of achievement out of it. I've learned a lot. And also there's a question of what I see as moral debt. So everybody in this room uses and has a huge debt to open source software. This is stone soup, by the way. Yeah? You put the stone in the water, and then if everybody contributes a bit of meat, a bit of veg, we wind up with a great soup. If nobody contributes anything, we've got a stone in a ball of hot water. And that's how I see open source. If we all contribute where we can, we will all have this rich environment of open source software that we can use to better ourselves. If you want to get involved, and I hope you do, you can learn more at fnproject.io. You can join the Slack workspace, you can follow us on Twitter, and you can fork us and contribute at github.com fnproject. Takeaways. Serverless is an abstraction. It's an abstraction that enables us to improve our productivity, our agility, the scalability, and the economics of what we do. FN is an open source serverless platform. It's Docker-based, it's portable, it's language agnostic, but there are multiple FDKs to help with some languages. Open source really matters. I think open source serverless really matters from the point of view of freedom. And if you care about that, then I think you should act like it, you should contribute, and you should help others where you can. Thank you. I'm Ewan Slater, and if you want to get in touch with me, that's the easiest way. We've got about 1 minute, 50 seconds for questions, if anybody wants. Yes, sir.
Before you mentioned that if you put all your eggs in one basket and you put all your functions seriously on one provider, if you get successful, they can steal your idea and basically your business. What did you mean by that? I mean, do they just steal your code? Do they have access to your code and they can steal it?
Okay, do you want to repeat the question?
Yeah, sure. So before you mentioned that if you put all your eggs in one basket and you put all your serverless functions and code on one provider and you become successful, they can steal your business. That's the greatest risk. So the question is, do they have access to your code? And if so, if they can actually rip off your code and use it?
So I wasn't thinking so much of them ripping off your code as just taking your business. So a few years ago, I did a project with a British building society, so like a mortgage bank. And part of the project was because they had noticed that other banks, they gave the mortgage, there was a direct debit to collect the mortgage, that other banks had been looking at the direct debits and thinking, they've got a mortgage with X. They've had that for about 2 years. Right, let's go and use the financial information we have to try and steal their mortgage business. So they were actually now having to offer current accounts in retaliation, which they'd never wanted to do before. There are other instances, I'm afraid, of unethical behavior. I'm not saying that anybody would. I'm saying it's perceived risk. And if you look at, say, Pivotal, you know, why are some of the banks using Pivotal? Because they also want to be able to have that option of being able to move their PaaS from a particular cloud provider to somewhere else if that cloud provider, say, decided it wanted to become a bank. It's about perceived risk. Yes, sir.
Tell me, please, what's a unique feature of FN project versus other serverless frameworks?
So, as I say, I don't want to be negative about anybody, so I will only talk about positives that people have said about FN project. So, Automate, who are here and gave a lightning talk yesterday, said they regard Flow as rocket fuel for what they've done, the orchestration mechanism that they've been able to use. There's a guy called Christopher Woods at Bristol University, has done some great talks you can see on YouTube, and he said, you know, he feels the maturity of FN and the portability that it gives him has enabled him to build a high-performance compute cloud based on FN.
Do you have high-order functions support of some sort, like sorts and high-order functions, sorts and everything that is sort of distributed?
You could write those, but they're not an out-of-the-box feature.
Right.
So it's because we're doing functions, we're not necessarily doing like functional programming.
Exactly.
Although you could. But yeah, maybe we need what's your functional language?
Used to be Scala.
Yeah, go ahead. Try some Scala. You could probably do that with the Java.
I knew you were going to
FDK.
say that.
Boomerang. Any more for any more? I suspect we're out of time. I will be around for the next hour or so, probably now down by the Oracle stand in the sponsors hall. If not, I hope you've had a great conference and I hope you enjoyed the talk.